So today in our notes, we're going to talk about absolute value equations. So if you remember, absolute value is the distance from zero. Any number is on the number line. So we use two examples to kind of remind you what that means. So if you say the absolute value of x is equal to 5, and you look at this number line really quickly, if this is 0 right here, then where would I have 5 spaces away? So 1, 2, 3, 4, 5. This would be a solution. And then 1, 2, 3, 4, 5. This would also be a solution. So this would be equal to 5 or negative 5. So how many solutions does the absolute value equaling negative 5? Well, the answer is it has none. The absolute value of something cannot be a negative number. It is the distance from 0, and you cannot be negative 5 spaces from 0. Negative is a direction, and you can't be actually in the hole on the number line. So let's talk about what that means then for solving problems. Clearly, we would not want an absolute value to equal a negative number, but before we can check that, we have to have the absolute value symbol isolated, just like we did when we were doing square roots. So when you solve a problem like this, you're actually going to solve it twice. You're going to solve it once, normal, so I'm going to do that one in blue, 3x minus 1 equals 4, or it could be the negative of that, 3x minus 1 also could equal 4. And so we're going to work both problems out and solve for two separate answers. So again, it's just a regular two-step when we get to this point. So we're going to add 1 to both sides. We're going to divide by 3, and we get x is equal to 1 2/3. Or, let me change back to pink. We're going to multiply by, remember if they don't tell you that's a negative 1 out front, so that is now negative 3x. A negative times a negative is a positive. And now we're going to subtract 1 from both sides. Then we're going to divide by negative 3. And we get an answer of negative 1. Because over here, x is equal to negative 1. So again, these are my two solutions. All right, let's try it again. Again, two potential solutions. The original problem, or this in parentheses, make the whole thing negative, and then it also equals 12. I'm almost out of room there. Let's make that just a tiny bit smaller. There we go. Okay, so now we're going to solve them. Again, that's the easy part because it's just a two-step. So we'll just go ahead and add our 4 to both sides. So that would be 16. We'll divide both sides by negative 2. We get y equals negative 8. Or now we do the negative side. So again, I'm going to distribute the negative sign. Negative and a negative makes it a positive. Another negative and another negative make it a positive. And now it's a two-step, so we'll go ahead and subtract 4. Divide by 2. And we get y equals 4. So here are our two solutions. Y equals negative 8 or y equals positive 4. Both of those would make a positive 12 solution. All right, so let's try one more of those. This time the only thing that looks a little differently is, as you can notice, there's an h on the other side as well. So we're still going to solve it the same way we did before. We're going to do it twice. So I'm going to solve it the original way. then I'm going to solve it again with a negative on this side. So at this point, it still looks the same. I just have the parentheses until I put the negative. And if you want, feel free to write the -1 if that makes you feel better, just so you don't forget. But now we have variables on both sides. And so a reminder, we subtract the smallest variable from both sides. So 1h plus 2 equals 3, and we will subtract 2h is then equal to 1. So there's my first solution. I'll do the same thing on the other side, only with the negative. So again, that is -2h, -3. So this time I'm going to add 2h's to both sides. Now it's still a two-step, so I'm going to go ahead and finish it out by subtracting and then dividing. And we get a final answer here of h equals -1. So these are my two solutions. As we look down here, the only thing that you're going to notice is that now, just like we did before, we have some things on the outside that have to be taken care of before we can solve the actual absolute value problem. Because as you look at these up here, notice the absolute value symbols were the only thing. Again, only the absolute value. There's nothing that is outside the absolute value on that side of the equation. So we're going to solve this like a traditional algebra problem to get the absolute value symbol alone. And I'm going to change color because I want you to realize that that is not the same as what we were doing before. So we have -5. Oh, so that would be what, 28? And we still have 2 times the quantity absolute value x, 3x minus 1. So now we're going to divide both sides by 2. Now we have 3x minus 1, and the absolute value symbol is equal to 14. And then the same thing here, only I have a negative sign. And if that had not been a -5 and we had something equal to a negative, we could have stopped. But because now I have a negative on both sides, this will cancel out. So 5 goes into 120 times and 5 goes into 15 3 times. So I end up with a positive 23. And in my absolute value, I have 3 plus 4k. Now, I am at the same point that I started those first ones on the notes on. I'm going to do this problem twice. And I'm not going back to the original. Notice I've already simplified it. So what we're doing right here is we're going to solve the problem so that the absolute value is alone. And then we're going to do all the same work by solving it for both methods. Again, I'm going to make it just a tiny bit smaller so I can stay on my half of the paper. Okay, so let me bring this down and go ahead and show you the two-step part on both of them. That gives me 15. Divide by 3. One of the solutions is 5. Clearly you can tell I'm at school. So this would be -3x. 2 negatives will make that a positive. You would subtract 1. It's not going to work out nicely because 3 does not go into 13 evenly. But I can write it as a fraction or an improper mixed fraction. 3 goes into 12 4 times with 1 left over. The decimal response, if you had been using a calculator, would have been -4.3 with a repeater bar. These are my two solutions. Again, I'm going to show you that again over here. So we have two math problems. 3 plus 4k equals 23. And negative times 3 plus 4k equals 23. So again, I am solving it both times. This right here is the hard part, knowing to simplify the problem down to the absolute value symbol, and then remembering that I have to do absolute value symbols twice because there should be a positive answer and a negative answer. And what you do notice is most of the time there is one positive answer and one negative answer, but that doesn't necessarily mean that they will end up that way because it's part of a equation. So again, let me go ahead and just show that real quick so you have everything all worked out for you in the notes. I get k equals 5. If I come over here and I do this one, I have negative 3 minus 4k because I distributed that, and it equals 23. We add 3. You know, negative 4k is equal to 26. And again, it does not go in evenly, but it doesn't go in badly. 4 times 6 is 24, so it's 2 left over, so it's 6.5. And so here are my two solutions. So again, solve for the absolute value symbol, set the problem up twice, and then go ahead and work both of them.